It's called entanglement.
The most bizarre, the most absurd, the most crazy, the most ridiculous prediction that quantum mechanics makes is entanglement.
Entanglement is a theoretical prediction that comes from the equations of quantum mechanics. Two particles can become entangled if they're close together and their properties become linked. Remarkably, quantum mechanics says that even if you separated those particles, sending them in opposite directions, they could remain entangled, inextricably connected. To understand how profoundly weird this is, consider a property of electrons called spin. Unlike a spinning top, an electron spin, as with other quantum qualities, is generally completely fuzzy and uncertain until the moment you measure it. And when you do, you'll find it's either spinning clockwise or counterclockwise. It's kind of like this wheel. When it stops turning, it will randomly land on either red or blue. Now imagine a second wheel. If these two wheels behave like two entangled electrons, then every time one landed red, the other is guaranteed to land on blue. And vice versa. Now, since the wheels are not connected, that's suspicious enough. But the quantum mechanics embraced by Niels Bohr and his colleagues went even further, predicting that if one of the pair were far away, even on the moon, with no wires or transmitters connecting them, still, if you look at one and find red, the other is sure to be blue. In other words, if you measured a particle here, not only would you affect it, but your measurement would also affect its entangled partner, no matter how distant. For Einstein, that kind of weird long-range connection between spinning wheels or particles was so ludicrous, he called it spooky. Spooky action at a distance. Clauser's machine could measure thousands of pairs of entangled particles and compare their spins in many different directions. As the results started coming in, Clauser was surprised and not happy.
I kept asking myself, what have I done wrong? What mistakes have I made in this?
Clauser repeated his experiments, and soon French physicist Alain Aspect developed a more sophisticated test. With significantly more definitive results, Aspect removed virtually all lingering doubt. Clauser's and Aspect's results are truly shocking. They prove that the math of quantum mechanics is right. Entanglement is real. Quantum particles can be linked across space. Measuring one thing can in fact instantly affect its distant partner, as if the space between them didn't even exist. The one thing that Einstein thought was impossible, spooky action at a distance, actually happens.
That is the most bizarre thing of quantum mechanics. It is impossible to even comprehend. Don't even ask me why. Don't ask me which we're going to, how it works, because it's an illegal question. All we can say is that is apparently the way the world ticks.
So if we accept that the world really does tick in this bizarre way, could we ever harness the long-distance spooky action of entanglement to do something useful? Well, one dream has been to somehow transport people and things from one place to another without crossing the space in between. In other words, teleportation.
Beam me aboard. Energize.
Energize.
Star Trek has always made beaming or teleporting look pretty convenient. It seems like pure science fiction, but could entanglement make it possible? Remarkably, tests are already underway. here on the Canary Islands off the coast of Africa.
We do the experiments here on the Canary Islands because you have 2 observatories, and after all, it's a nice environment.
Anton Zeilinger is a long way from teleporting himself or any other human. But he is trying to use quantum entanglement to teleport tiny individual particles. In this case, photons, particles of light.
Nanometers, it says.
He starts by generating a pair of entangled photons in a lab on the island of La Palma. One entangled photon stays on La Palma, while the other is sent by laser to the island of Tenerife, 89 miles away. Now Zeilinger brings in a third photon, the one he wants to teleport, and has it interact with the entangled photon on La Palma. The team studies the interaction, comparing the quantum states of the 2 particles. And here's the amazing part. Because of spooky action, the team's able to use that comparison to transform the entangled photon on the distant island into an identical copy of that third photon. It's as if the third photon has teleported across the sea without traversing the space between the islands.
Sort of extract the information carried by the original and make a new original there.
Using this technique, Zeilinger has successfully teleported dozens of particles.